Hi everyone, welcome to my channel. This is Quantum Unicorn. In this episode, we are going to pick up where we left off last time and break down all the code we covered in the previous video. I'm going to explain the syntax structures, statistical principles, and financial concepts behind the Python code in a systematic way. How exciting! Let's dive right in. Oh, by the way, if you haven't been following along with the video so far, then I have a link in the description section below that links to where you can download all the data files so you can follow along with this. Okay. And just a kind reminder, this course is meant for educational purpose only. The data and information presented in this video is not investment advice. Okay. And please subscribe to my channel, like the video, and click the bell icon on to receive the latest updates. Thank you. Well, first, we need to import the necessary packages such as NumPy, Pandas, and Matplotlib. We will use Pandas to read the stock data from a CSV file and set the index to the date column. Then we will plot the closing price of Apple stock from August 2012 to August 2013 using the look function. And this set of codes imports the necessary packages for data analysis and visualization. NumPy is used for mathematical operations. Pandas is used for data manipulation, and Matplotlib is used for data visualization. Then we use this line of code to read the Apple CSV file located in the data CSV folder and stores it as a Pandas data frame object named AAPL, Apple, right? Then the head method is used to display the first 5 rows of the data frame. After that, we use this line of code to set the date column as the index of the Apple data frame. It then plots the daily closing prices of Apple stock from August 1st, 2012 to August 1st, 2013 using the log function. The in place equals true parameter ensures that the change is made to the data frame object itself rather than creating a new one, right? And the third line of code selects a slice of the data frame based on the date range 2012 August 1st to 2013 August 1st and the close column, and then plots the data using Matplotlib. So in terms of statistical concepts and financial theories, this set of codes is related to time series analysis and visualizing financial data. By importing and manipulating stock data, we can analyze how the stock price of a particular company has changed over time and use that information to inform investment decisions. The plot function allows us to visually analyze the trends and patterns in the data. Overall, this code provides a foundation for exploring and analyzing financial data using Python. Okay, after that, let's move on to the next step. Here we are going to plot the histogram of the log returns. The first line of code creates a new column in the Apple data frame called log return, which is the log of the daily return of the Apple stock. The NP log function calculates the natural logarithm of the close price column, and the shift -1 function shifts the resulting array by 1 index position. we subtract the original log of the close price column from the shifted log values to obtain the daily log returns. The second line of code generates a histogram of the daily log returns of the Apple stock using the hist function. The bins equal to 50 parameter specifies the number of bins to use in the histogram. So, in terms of statistical concepts and financial theories, this set of codes is related to the calculation and analysis of daily stock returns. Log returns are commonly used in finance because they allow us to uh, interpret changes in stock prices in percentage terms, and they have desirable statistical properties such as being approximately normally distributed. By analyzing the distribution of log returns, we can gain insights into the volatility and the risk of the stock, which are important factors in investment decision making. The histogram provides a visual representation of the distribution of log returns, which can be used to identify any outliers or patterns in the data. Okay, after that, here let's try plot a histogram of the log returns and compare it to a normal distribution. This can be done using the SciPy-Stats module to calculate the probability density function and cumulative distribution function of a normal distribution. The first line of code imports the norm function from the SciPy-Stats library. The norm function is used to generate a normal probability density function, that's PDF, right? And the second line of code calculates the mean of the daily log returns of Apple stock using the mean function. Sigma is the standard deviation. So this line calculates the standard deviation of the daily log returns of Apple stock using the std function with the DOF parameter set to 1. The DOF parameter adjusts the calculation for the degrees of freedom. Density, this line, the density creates a new empty data frame object called density. And then density X creates a new column in the density data frame called X, which is an array of evenly spaced values between the minimum and maximum log return values of Apple stock, incremented by 0.001. This array of values will be used to plot a probability density function of the log returns of Apple stock. Here is a breakdown of what's happening. So Apple log return refers to a pandas series that contains the log returns of Apple stock. And the mean returns the smallest value in the series. And then it subtracts 0.01 from the smallest value, which ensures that the PDF plot starts slightly to the left of the smallest log return value. This is done to avoid cutting off the left side of the plot. And then the max returns the largest value in the series. And it adds a 0.01 to the largest value, which ensures that the PDF plot extends slightly to the right of the largest log return value. This is done to avoid cutting off the right side of the plot. So the NP arrange start stop step is a NumPy function that returns an array of values that start at the start, stop at the stop, and are incremented by step. In this case, it creates an array of values between the adjusted minimum and maximum log return values. With the step of 0.001, these values are assigned to the X column of the density data frame. Overall, this line of code is creating an array of values that will be used to plot a smooth probability density function that represents the distribution of the log returns of Apple stock. Okay, and then density PDF. This line of code creates a new column in the density data frame called PDF, which contains the probability density function values generated by the norm PDF function using the X, mu, and sigma variables. The next line of code generates a histogram of the daily log returns of Apple stock using the hist function with the bins parameter set to 50 and the fixed size parameter set to 10.6. And next, the PLT plot. This line of code generates a plot of the normal probability density function using the X and the PDF columns of the density data frame. And then we use the PLT show function to display the plot. Okay, so in terms of statistical concepts and finance theories, this set of code is related to the visualization and analysis of the distribution of daily log returns of a stock. By comparing the distribution of log returns to a normal distribution, we can assess the degree to which the stock returns follow a normal distribution. The norm function is used to generate the normal probability density function, which is then plotted alongside the histogram of the daily log returns. The plot shows that the distribution of log returns is very close to a normal distribution, which has important implications for portfolio optimization and risk management. Okay, moving on. Next, here. The density PD data frame. This line creates a new pandas data frame called density that we will use to store the PDF and the CDF values. The density X, this line creates a new column in the density data frame called X that contains a range of values from -4 to +4 with a step size of 0.001. This range of values represents the domain of the PDF and CDF. The density PDF equals norm PDF density x01, and this line calculates the PDF of a standard normal distribution for each value in the X column. This standard normal distribution has a mean equals to 0 and a standard deviation equals to 1. The norm PDF function takes 3 arguments: the range of values X, the mean 0, and the standard deviation 1. And the density CDF, this line calculates the CDF of a standard normal distribution for each value in the X column. The norm CDF function also takes 3 arguments: the range of values, the mean, and the standard deviation, which is 1. So in terms of statistical concepts, this code demonstrates how to compute the PDF and the CDF of a normal distribution. The normal distribution is a bell-shaped curve that is often used to model random variables in statistics and finance. The PDF represents the probability density of a random variable at a given point in the distribution, while the CDF represents the cumulative probability of the variable up to a given point in the distribution. In finance, the normal distribution is commonly used to model stock prices and other financial variables, as they often exhibit a pattern of behavior that is similar to a normal distribution. The PDF and CDF of a normal distribution can be used to calculate probabilities and make predictions about the behavior of these financial variables. The Python code PLT plot density X density PDF is used to plot the probability density function of a standard normal distribution. The density X is the range of values on the x-axis representing the domain of PDF. Density PDF is the probability density function values on the y-axis representing the probability density of the corresponding values on the x-axis. The PLT plot function is a matplotlib function that is used to plot data on a two-dimensional graph. In this case, it takes two arguments, density X and density PDF. The code will create a line plot of the PDF of a standard normal distribution. In terms of statistical concepts, the PDF represents that the probability density of a random variable at a given point in the distribution. The PDF of a standard normal distribution is bell-shaped. Is a bell-shaped curve centered at the mean, which is 0, with a standard deviation of 1. The PDF is used to calculate the probability of a random variable falling within a certain range of values. In finance, the PDF is commonly used to model the distribution of stock returns and other financial variables. Understanding the PDF can help investors make decisions about their portfolios and assess the risk associated with their investments. Okay? Then the Python code PLT plot density X density CDF is used to plot the cumulative distribution function of a standard normal distribution. The density X is the range of values on the x-axis representing the domain of CDF. Density CDF is the cumulative distribution function values on the y-axis, representing the cumulative probability of the corresponding values on the x-axis. In terms of statistical concepts, the CDF represents the probability that a random variable takes on a value less than or equal to a given point in the distribution. The CDF of a standard normal distribution is the S-shaped curve that starts at 0 at negative infinity and approaches 1 at positive infinity. In finance, the CDF is used to calculate probabilities and assess risk. For example, the CDF can be used to calculate the probability of a stock price falling below a certain level or the probability of a portfolio losing a certain amount of value. The CDF is also used in option pricing models to calculate the probability of an option expiring in the money. Okay, so that's all for today. That's all for today's tutorial, folks. We will cover the rest in the next episode. So when you come back, please make sure to take some time to digest and organize all the info we covered here. And remember, practice makes perfect. So keep working hard and experimenting with what you have learned. I certainly hope that you had a good time listening to me and understood all of it. Um, but if any of the financial theories or statistical concepts we talked about are still a bit of mystery to you, just drop me a comment. I'm more than happy to give you some extra context or examples to help you out. And speaking of comments, I'm always open to your feedback and suggestions. So if you have got any thoughts on how we can make this show even better, please don't be shy about sharing them. Thanks a lot for your support. And before we sign off, please give this episode a like, subscribe to my channel, hit that notification bell, and share it with anyone you think might dig it. All right. Take care, and I will catch you all in the next episode. Goodbye.